Second task, you see, use the stem function to create a plot of y against x. Stem, I told you, plot, if I give, see here, plot is a continuous time. And staircase is it's a discrete. It's a, I won't say it's a digital, because digital means 0 or 1. It's a discrete waveform. Discrete means it has different levels. And stem is a completely discrete. This is a discrete plus continuous. It's a mixture of continuous and discrete, because you have a stem, you have a flat value, and again the waveform is also continuous, right? So first one is completely continuous. Second one is partially discrete, partially continuous. And now I'm going to use the stem function to plot x versus y. So stem of x comma y. And you know how the graph should be. You will have the signal only at distinct instance of time. So if I run this, if I give submit here, you will get the answer. See here how perfectly you're getting a discrete time. Maybe I'll zoom it. You will see even more better. It's over zoomed, sorry. I'll reduce the zoom. And I think you can see now how the waveform is discretely available at each and every points of time. So this is a discrete time sine signal. This is the first one is a continuous time sine signal. I hope you can understand the difference between both. This signal is continuous. You have value for every time, for every value of time, you have the signal value. But in discrete, it is available only at specific instance of time. Okay, I hope this is clear. We'll go to the next task. Use the area function. So first plot is already given to us in this problem. So plot gives a continuous time signal. Star gives a staircase type signal. Okay. And stem is going to give a discrete time signal. Now I'm going to use the area function. So area of x comma y. Now I'm going to submit and see what is the answer I'll be getting if I'm going to use the area. Yes, so this will shade the entire area of y against x. See, x is varying from 0 to pi. So see here it is shading the entire area from 0 to pi. Is that clear? That is why you see in sine wave, if you see the area, the positive in the positive half of sine wave, the area is it will be the area will be positive. The negative half, the area will be negative. See, actually area is always positive, but if you see sine wise, the area is positive in the upper half. For the negative half cycle, the area is negative. So if you take total area, it is going to be averaging out. So average value is going to lie always at 0. For a proper sine wave, the average value is going to be 0. It has 0. The DC value of sine wave is going to be 0. So we have executed the plot commands, and we have executed the different commands to plot, staircase, stem, and area, and each one is different in their own way. You can see the answer of each of these graphs. It's going to be different, and all these graphs provide better visualization of how you can project the data.